Hello everyone, welcome to this short video on troubleshooting Wi-Fi and understanding how speed tests work. So, starting points. First thing I want you to understand is low speed test results are not the same as intermittent services. We can often have times where customers call in just because the speed tests are not where they want them to be, but that doesn't necessarily mean that they're having intermittent services. So please don't conflate low speed tests with intermittent services. The next thing is you can have a low speed test while also having a perfectly good Wi-Fi connection. And then you can also have a very high speed test while at the same time having a very intermittent connection. So key thing to understand is not always easy to conflate speed test with intermittent Wi-Fi. Troubleshooting in layers. This right here is a fundamental concept that if you grasp it, it would help you understand how speed tests work, especially with throughput and hardwired and Wi-Fi. Example 1. At layer 1 we have the throughput, the coax, which is what we find through DOCSIS. At layer 2 we have our Ethernet, our hardwired speeds. In layer 3 we have our Wi-Fi, which is over the air. The reason I classify these as a layered approach is because each layer builds upon the layer before it. So if we start off at layer 1, which is our throughput, is what we get off the plant, which is what we find through our DOCSIS. That is the starting point for our hardwired Ethernet speed, and our hardwired Ethernet speed is also the starting point for our Wi-Fi over the air. So our hardwired Ethernet speed is based upon what we have on our throughput, and our Wi-Fi is based upon what we have on our Ethernet. Here's another example of that with different terminology. So at layer 1, and when I say layer 1, I'm not in layer 2 and layer 3, I'm not referring to the OSI model, so don't get that confused. This is something that I made up. So layer 1, which is our throughput, which is our starting point, and then that builds upon to the modem. So the modem is governed by the throughput that comes off of the coax. And then we have the Wi-Fi. The Wi-Fi is governed by the modem speeds. So conceptually, each layer builds upon the layer before that. And here's an example of what I mean by that. So let's say we check our throughput, and let's say we're getting 1,000 megabytes at the tap, which is a gig. And then we go to check our hardwired speed or our modem. That may be a little bit less. Let's just say that's going to be 900 megabytes per second. And let's just say we go to check our Wi-Fi, and let's say we're getting 600 megabytes per second. Typically what you're going to see is that when you check for throughput and you check your hardwired and you check your Wi-Fi, typically what you're going to see is that the numbers diminish. So what you have at the throughput is often going to be substantially more than what you have on Wi-Fi. You're never really going to see, unless you have something going on with your meter or something intermittent, you're never going to see your Wi-Fi speeds be more than your hardwired speeds, and you're typically never going to see your hardwired speeds more than your coax throughput. So what is the difference between throughput and bandwidth? So assume your meter is a modem, because essentially it is. Now let's assume your meter is a modem with no provisioning limits. So your throughput is your speed via DOCSIS that your modem receives from the plant. So throughput is what the plant is delivering to the home. So here's a distinction between throughput and bandwidth. Throughput is not subjected to provisioning guardrails, while on the other hand, bandwidth is subjected to provisioning guardrails. What that means is, if your customer is paying for 300 megabytes, that will not impact your throughput, but it will be capped off for your bandwidth. Another thing we could also say is that your bandwidth obeys your throughput. So going back to what we stated earlier, your throughput should never be less than your bandwidth. Your bandwidth should always be compliant to what your throughput is. So what relationship exists between throughput, your hardwired, and your Wi-Fi? So this chart right here represents what I call a step-down theory behind the speeds that you're going to get. So let's just say you're getting 1,000 megabytes on your throughput. You may get a little bit less as we stated earlier, a little bit less on your Ethernet speeds, and then you're going to get a little bit less on your hardwired speed. This is a natural phenomena in how Wi-Fi and speed tests and all that works. This is something we don't really have control over. It's just the way things work. So when you check your throughput, you're going to notice that it's going to drop a little bit once you get to your bandwidth, which is your Ethernet, and then it's going to drop a little bit once you get to your Wi-Fi. So as we stated earlier, your Wi-Fi should never be more than your Ethernet test, and your Ethernet test should never be more than your throughput test. And if it is, you've got another problem there. Here's the real relationship between Wi-Fi speeds and Ethernet speeds. In this example, I exaggerated the difference between Wi-Fi and Ethernet speeds. Your Wi-Fi speeds are going to be way less than your Ethernet speeds typically. So if you have, let's just say you're getting 1,000 right here, it's okay if you're getting 250 for your Wi-Fi. That can happen. That doesn't mean you have a bad connection. So understanding what happens between the layers, and I've exaggerated the spacing of this right here. So if you look at your throughput and your hardwired speed, this spacing right here, there's not a lot of spacing in here. The reason why, it's not a lot that happens between your throughput and your Ethernet speed. They're typically going to be very synonymous to each other. The only thing that should have any kind of impact on that is what the customer's provisioned for, and potentially issues with your devices such as your modem and your router. But however, there is right much of a difference between your Ethernet and your Wi-Fi. There is a whole nother world of problems that can take place between Ethernet and Wi-Fi. So when that data transfers from Ethernet to Wi-Fi, you have a whole nother world to deal with. And no pun intended, but you have the world as part of your culprit of issues, because it becomes over the air. So once the data becomes over the air, you have a whole nother list of things that are happening, such as interference. You may have other devices that are broadcasting over the air. Wi-Fi is a shared medium, and it is shared with things that are not on your network, as well as things that are on your network. So Wi-Fi itself is just more vulnerable to many more things versus Ethernet. So that's one of the reasons why you're going to get a lower speed test off of your Wi-Fi, including many other things. Two very important concepts. Point number one, we cannot guarantee speed tests over a Wi-Fi connection. Speed tests are going to vary specifically on Wi-Fi connections, as we just stated earlier. Point number two, we really can't guarantee speed tests on customer-owned devices. So here's some attributes of customer-owned devices that have a big impact on speed tests. The first thing is going to be anti-malware. Also included in anti-malware is often going to be included are host-based firewalls and also encryption protocols. Those are all going to be kind of embedded into some kind of anti-malware program. With a lot of customers that work from home, you're going to often see corporately enabled devices, and these devices are what we call hardened, which means they're going to have all kinds of security stuff on them. That's going to have a big impact on speed tests. Another thing is going to be your network interface card. So when you run a speed test, your results are going to be capped off of whatever your network interface card is rated to do. So if your network interface card is rated to only do 300 megabytes per second and you're testing a gig speed, you're not going to get a gig speed because your device itself is not designed for it. Another thing is CPU usage and congestion. The device itself, the computer that you're running the speed test on, the performance of that in itself has an impact on the speed test and quality of the network usage. Another thing is whatever frequency that device is communicating on, particularly through a Wi-Fi connection. So the higher the frequency that it's operating on, the higher the speed test you're going to get. So if you got a device that's operating off of 2G, you're probably not going to get a good speed test. So be very mindful of what kind of network your devices are connecting to, 2G or 5G. 2G, you're not going to get a good result. The age of the device. So if you have a customer that's running speed tests on a computer that's 5 years old, you got to think, we were not deploying gig networks 5 years ago. If we were, it was very, very limited as today. So those computers 5 years ago were not being manufactured to test a gig network. So why is it that speed tests are unreliable? First thing, let's define what a speed test is. When you run a speed test, your device is pinging a specific server and measuring the quantity of ICMP packets over time, there and back. An ICM packet is pretty much just a dummy packet. It's just designed for testing network connections. The server you are pinging is typically predefined by the speed test tool. So that means if you go to run your speed test, you can often change your server, but you only have a limit of options of which servers you can hit. And the third thing, which is probably the most important concept here, speed test routes are subjected to heavy congestion. Consider how many people are running a speed test at the same time as you hitting the same server. So if that server is over congested and the path route to get to that server is over congested, you're going to get some pretty fluctuating numbers on your speed test. And here's the last thing I want to talk about: speed test delusion. Speed tests are not a point-to-point communication. So if you check out a speed test website such as Ookla right here, I believe we're on Ookla, speedtest.com.net. So from what I'm looking at, it looks like I'm on our network and I'm pinging a server on Ripple Fiber in Charlotte, North Carolina. Now, the misconception is that you're going from your computer to that server directly. That is a misconception. And what is actually happening is, so instead of hitting their server directly, what you're really doing is there are a lot of things in between you and that server, other routers and networking devices that you're going to have to hit before you get to that server. So it's really going to look like this right here. And the path that packet takes to get to that server plays a huge impact. So the more things that are between you and the server, the more latency you're going to have with your speed test. And the actual definition of that right there, what we call that, is hop count. And I'm going to give you an example of what I mean by this so you can defend your case if you ever have to. So if I run a speed test, now I'm connecting from our network to the Ripple Fiber. I'm getting pretty low speeds. That's because I'm on a corporate network right now, and I'm on a guest network, so that's probably got something to do with it. But I'm getting 110 megabytes per second. Now, if I click on that server, and I'm going to open up, this is something you can't do on your phone, unfortunately. You have to have a computer to do it. But if I go into command prompt and I run a trace route, let me take the cap off of there, and I hit that server, look at that, tracing route to ripplefiber.com over a maximum of 130 hops. That means, I mean, not 130, I mean over a maximum of 30 hops. Excuse me there. So what that's telling me is there's over 30 points in between me and that server. So that's going to cause latency on my speed test. And what we're looking at right here is pretty much a live itemization of every single one of those hops that ICM packet is taking. And that right there is just proof that it's not a point-to-point communication, and that this right here is a pretty big factor in your speed test. And it's something that unfortunately, we cannot control. So, hope this was informative. If you have any questions on this, just reach out to me. Thank you.